Let us continue looking at relation, functions, and graphs. We want to look at a relation that is not a function. Now, previously, we had looked at an example such as this, one value being mapped onto one other value. This is a one-to-one mapping. We also looked at another case where we have the arrow diagram. We have both oval, that's for the domain, that for the range. And we have one value mapped here. Then we have another value mapped. Another one mapped to one number. This one is mapped onto this same number. This one is mapped onto this same number. What we have is a many-to-one mapping. Many-to-one. The one-to-one is a function, and the many-to-one is also a function. However, the one-to-many, as we saw previously, is not a function. And we want to look at an example. One example is this. You have f of x is mapped onto the square root of x. Now, when you have a case like this, you accompany it with the positive and negative. And we're going to see why. Suppose you have x, let x equal 4. What is f of x? Now, remember, the square root of a number is another number. Now, this other number, you square it and you get back your first number that you're trying to find the square root of. Alright? That number, which is the square root, when you multiply it by itself, you get the number that you're trying to find the square root of. So, for 4, let us see which number multiplies itself to give 4. A number multiplies itself to give 4. Well, 2 times 2 is equal to 4. So, therefore, 2 is the square root of 4. So, plus or minus the square root of 4, which is 2. But hold on. It also works for another number. There's another number that multiplies itself to give 4. Which number is that? Negative 2 multiplied by negative 2 also gives 4. So negative 2 works as well. So it's 2 and negative 2. So that's why you put the plus and minus 2. This 2 and negative 2 as well. Let us start putting our values in our arrow diagram. We have 4. This is our f of x. And plus or minus the square root of x. The square root of 4, let us say, of 0, 1, 2. Let's not put in the 1. Let's not put in any unnecessary number now because we need a space. 2 and negative 2. What you see is 4 is mapped to 2 and 4 is mapped to negative 2 as well. Already you can see that this is a one-to-many mapping. It's not a function. You could put in another number in it. Suppose I want my x to be 9. Which number multiplies itself to give 9? You know that 3 times 3 gives 9. So when I have 9 here, 3 is one of them, one of these numbers. But then negative 3 multiplied by negative 3 also gives 9. So I could put a negative 3 down here, and 9 will map to 3, 9 will map onto negative 3. So again, you have a one-to-many mapping. One person had voted for 2 candidates, and that's illegal. Now, we could also put 16 as one more. 16. So let our x be 16. So f of 16 is equal to plus or minus the square root of 16, which is plus or minus 4, because 4 multiplies itself to give 16, and negative 4 multiplies itself also to give 16. So we can put our negative 4 down here and our positive 4 down here, and 16. When we put 16 in the domain, find the square root of it to get the range. 16 mapped, let's not go inside the oval. 16 is mapped onto 4, and 16 is also mapped onto negative 4. So when you see a relation with a square root sign, you can tell quickly that that is not a function. Alright? So, where x is the variable and you have a square root of x involved, you have a relation there, but it is not a function. It will lead to a one-to-many mapping. Alright? So, it's not a function. Alright, we'll continue functions or relations in another video.